Right, for our next section, our next check, our section 6 here, we're gonna go 33 to, I think it is I forgot, 61? No, 49. Let's see, hold on. This section, yeah, okay, 43, and then we're actually gonna go to 61. It is 61. Okay. All right, so function notation, things we need to know. So things we need to kind of start off with. Function notation is when we have this f of x here. It is that f of x is just like the y value. So there's two parts for function notation. X, which is the input, which is like your domain, the things we're plugging in to the function, and y is the output, the result, what comes out when we plug in that number. So on a problem like this, we have the function f of x equals x squared plus 9. We want f of 3. Anything inside the parentheses, this represents, and I meant to make that blue, sorry. This represents, that number represents x, okay? So we're plugging in the 3 in front of the x, inside of the x, okay? Instead of in front, but in the x. So anytime we're dealing with plugging in, we have to use parentheses to indicate that. So we would have parentheses squared plus 9. And what we're plugging in here is this 3 in place of that x squared. And then we're just going to do order of operations. Exponents first, so this would be 9, and then plus that 9. So our answer here is 18. That's the output. So f of 3 equals 18. Or you can think of it as the order pair. 3 is the x, so 3 comma 18. So all we're doing is asking you to plug in and get to the value, get to the output. Now there is a shortcut because anytime I have function notation, this is the same thing as y. So you could use your calculator to get to an answer. And let me just remind you how to do that. Since g sub x is the same thing as the y value, I'm trying to basically cover this with the y. Then we're putting in the equation y equals, I'm just going to write here, negative 3x plus 1. So, excuse me. So if you go to your calculator and you go to y equals here, I need to clear this one out, and you put in your negative 3x plus 1, hit enter, but then go to the table, so hit second graph, and this will give us our value. So we were trying to find the value of the function, the g sub function at 10. So if I would just, you can just arrow down and just highlight the x value of 10, sorry, and there is our answer. So it would be a negative 29. So you could use your calculator to do some problem solving. That's fine, okay? Now, I do want you to be able to find the input and output off of a table, okay? So anything with the x values is your input, the f of x, that's your output. I'll just erase that right there, sorry. All right, so to get our solutions, we have to read it off the table. So they want f of 3. 3 is the x. 3 is in the x column. So we go to where that 3 is, there it is, and find the output. Look across. So this answer is 9. That's all we're doing, is getting the answer off of the table. Now, on this next set down here, where it says if the function equals 9, remember f of x is y. So if I know the y value is 9, what is the x? So we're kind of working backwards here. Well, we already did that one. Let's look at this one. What is the x when the function is 11? So what I do is I look on the table, I find that 11, and then I go and see what is the x there. So here x would equal 4. Now, if the numbers are not in the table, then we have to say it does not exist, because we have to get our answer out of the table that's given. So on 35, they want you to use the graph to find the function. Okay. All right, hold on just a second. Okay, so what I wanted to kind of highlight it, let me get that pen right. So since we're talking about the graph of the function is the actual curve here, the yellow curve. I just highlighted it. So if I want to find our answers off the graph, I'm actually finding actual points that are on that curve, okay? And you got to remember, points are like order pairs, x and y's. So if I'm doing the function, it's our x, our input, and our y, which now is our f of x. So we can think of an order pair as x and f of x. So if they want you to find the value of the function when for f of 2, this is when x equals 2. So what you have to do is go to this x-axis, okay? Find 2. 1, 2, 2 is right here. Let me fix my font just a second. And then we have to find the point on that curve. So that point is right here. And that order pair is 2 comma negative 2. So the function at 2, it equals a negative 2. That's all we're doing, okay? Now, on this other section, you got to work backwards. They want you to find the x. I'm going to change my font here, the color. Find the x when the f of x equals 2. So we have to understand that we're looking for what number gives us. Well, we kind of had it here. So let me talk about basically, this is the y value. So you have to go to the y-axis, find the negative 2, and then find that point on the graph. So we did that one. Now on this one, when the function equals 0, the 0 is here, and then there's a 0 also right here. Okay, that's when the y is 0. We want the x values though, because this is find the x. So the x, let me just make sure we're just focusing on the point. This point and this point. The x happens, the function 0 at 2 places. It's when x equals a negative 5 and also when x equals 0. So you might have 2 answers, looking off the graph. Now, for problems like this, when you don't have a graph or a table, you're going to have to use pencil and paper to solve. So it says if I let the g sub x equal negative 3x plus 1, if g sub x equals 14, so remember, not 14, 16, sorry. Remember, this is the output. This is like my y. Remember, your function notation is like a y. They want us to find the x. So to do that, you have to take this 16 and plug it in place of y, and then rewrite it. So this is going to be 16 equals negative 3x plus 1, okay? And now we're just solving the equation. So we're solving for x, so we have to isolate this x term by doing the inverse, so minus 1, minus 1. We end up getting 15 equals negative 3x. Then if we just divide that by the coefficient, the number in front of x, which is negative 3, and we get the x value, I'm just going to come over here to the side, equals negative 5. Okay, now if you're not sure, remember, these function notation is the same as a y. So if you're not sure, you could always go to the calculator, go to your y equals, type it in, and then go to your table. And we're looking on the table when the y column, when the output is 16. So here, these are all negative. So that means I need to go up. I need to go back. And then I can see right there, when x is negative 5, the output is 16. So you could use your calculator to get your answer here as well. All right, so now we're going to determine if our relation is a function. That means no repeating x's, and then find the domain and range. Remember, our domain is x, our range is y. We did that on the graphs. Now we're going to do this from set notations and from mapping. So if it's 2 circles here, the mapping, we're just listing the domain. And I think I'm in blue, yeah. So that's just this first set here, and this would be 6, 7, and 8. The range is the y circle here, and that would be negative 4, comma 3, comma 1, comma 5. And usually we use a bracket set notation like that. Okay, now to determine if it's a function, we can't have repeating x's. Now in mapping, what you're going to look for is if these lines that are showing what numbers map to split. So like right here, there's a split. This indicates it's the 6 is mapping to 3. And 6 is going to 5. So it's repeating. The 6 is repeating. So this would be, no, it's not a function. Okay, so check your x for your domain, okay, and check that it doesn't repeat. All right, so you take care of, oops, sorry. That's supposed to be green. You take care of that one. All right, on our next page, because we're trying to get this section done, now we're going to get into domain and range on a graph. Okay. So when we read it on the graph, sorry, we have to look to the left and right of the graph, because domain, remember, are the x-axis here. Okay, and I'm gonna make that a little smaller. Sorry. So I go to the left of this graph. This graph is the triangle. So here's the left part of the graph, and it actually touches the x-axis right there at a -3. Okay. And then I go to the right. Well, here's how far right it goes, but look down. You got to look at the values on the x. That happens at 3. So my domain is, the left is a -3, so it goes from -3 is less than or equal to x, which is less than or equal to the +3. So we scan on the x-axis from left to right of the graph. Now, range is your y values. Okay. Oops, I'm going to do that in red, sorry. This is our y-axis right here. So we have to go to the bottom of the graph. The bottom is here, but you have to look on the y-axis. It's right there at a -2. The top of the graph is here, but you still have to look on the y-axis for range. So this would be a -2 is less than or equal to y, which is less than or equal to the 4. Now we're doing the equal to the line underneath because this is solid lines here on the triangle. If it's an open circle or dashed line, we wouldn't have the equal to. And then it says here to determine it's a function on a graph, you have to do the vertical line test. That means you basically draw a vertical line on the graph and check to see does it intersect or touch the graph twice or more than once, basically just more than once. So this happened 2 times, so this is not a function. It can only touch the graph once, the vertical line. And it doesn't matter where you draw the vertical line. Like I put it there, it's still going to intersect twice right there. All right, so to determine your domain and range for a function like this that has arrows, we need to talk about this one because this is going to be a little bit different. Domain is still going to be the x value. You're scanning left to right. So if I go left, here's the left of the graph. It's at a -4 there. But the right of the graph is this arrow. That indicates that the graph keeps going. Anytime I see an arrow, it means it's moving to infinity. And since this is pointing to the right here, which means this keeps extending out, this would be a positive infinity. Anytime I have a number and just a number to an infinity, we're not going to have 2 inequalities like we did in 41 and 40 here. We're just going to have 1 inequality. This is my starting number, and it keeps going to the positive direction. So if it's pointing to the right, that's where our inequality needs to point because it's saying it's getting greater than. So x here is greater than or equal to the -4. Okay. Now for the range, we're still doing bottom to top. The bottom of the graph is here at this arrow, excuse me, and the top of the graph is here. So I look to the y-axis, that happens at 3, and the bottom keeps pointing, this is pointing down, which means it's gonna, sorry about that. It's gonna keep going down the y-axis. If it's pointing down, that's a -infinity. So remember, again, if I only have 1 infinity symbol, then it's going to be only 1 inequality symbol. Okay, so it starts here at 3 and it points down. Down is being less. These numbers are getting smaller and smaller from 3. So this would be y is less than or equal to 3. Okay, so if it points down, it's less than. If it points up, it's greater than. If it points right, it's greater than. If it points left, it's less than. Okay, now is this a function? Well, if I do my vertical line test on this graph, it only touches, the vertical line only touches once. So this would be yes. Okay, so make sure you understand if it's going to have 2 inequalities. Usually it's 2 inequalities if you have 2 numbers. But if you only have 1 number and an infinity, it's not going to be 2 inequalities. So we can kind of check your understanding with 42. If you want to pause and try to do the problem. I do want to talk about this one just slightly because there is a symbol we need to use for our domain. All right, so make sure I'm in the right color. All right, left to right. If I scan left, it would be right here where this arrow is, which means it keeps going out, So this is negative infinity. This is the right arrow, keeps going up, which means it will keep going out, positive infinity. So two infinities, negative infinity is less than x, which is less than positive infinity. The thing you have to memorize or remember is if I'm doing from negative infinity to positive infinity, that's all the numbers from negative to positive. So this is like saying all real numbers. Now, there's a symbol for that. Instead of writing that out, take that off, you can just put the double R, and that's all real numbers. Our range here, okay, so all real numbers for that domain. This is the bottom of the graph right here. This is called the vertex, where we get to the lowest point on the parabola, the curve. But you have to look at the y's. So there's our range, our bottom of our graph. But then the graph, if I follow the curve, keeps pointing up, keeps going up. So basically it's starting down here, but it keeps going up. And if it's pointing up, that's positive infinity. Again, if this is a number and an infinity, this is the starting point, and it keeps going up. So this would be y is greater than or equal to -2. And is this a function? This one you should also have yes. All right, so just try to see if you can do number 43, check your understanding, and then we're going to get into linear equations. All right. Hopefully, we are seeing two numbers. We're using two numbers for both of these on our domain range. All right, so to wrap it up for our third check, we need to remember parts of linear equations, which is our y equals mx plus b form. This is a form we want to, there's two things we really want to focus. We need to know our m represents the slope. I probably need to change the fonts on that. Okay, m is our slope, and our b is our y-intercept. So in order to see these two parts, which is what they're asking us to fill in, we have to have the equation solving for y. The y has to be by itself. So if I look at this equation, it's in standard form. It's not solving for y. So we have to isolate this y term by subtracting 6x on both sides of the equal sign to cancel the x term on the left. Now, when I do that, I'm just rewriting everything. So we should have 4y is equal to -6x plus 2. Now, we still have this coefficient with the y. We have to divide everything by that coefficient, the number in front of y. So we're dividing by 4. And this cancels. But we have to simplify this. We can't just keep it improper, just not reduce. So this final answer would have been y equals a -3 over 2x plus 1/2. And we should see that the slope, which is always the number in front of x, is the -3 over 2. And the y-intercept, which is being added or subtracted to the slope, is the 1/2. Okay? I do want you to try to do number 39. It will be fractions answers as well. And while you're attempting that, I'm just going to give you some key facts about rate of change on 46. I'm just going to write it down while you're working. All right, so if you attempted 45, hopefully you got your slope is the fraction 1/4. And your y-intercept is the fraction 5/8. So check your work, make sure it matches to these answers. Now, rate of change on 46. Okay. Rate of change is the same as slope. Rate of change means slope. And whenever we're trying to find slope, we need to use the slope formula whenever we have points. So that's y2 minus y1 over x2 minus x1. So we're using this formula with the points in this table. Doesn't matter which points we have, we just need to pick two. So I'm just going to pick the first two here. I'm going to plug it into the formula. This would have been 3 minus 12 over 0 minus -2. So -9, this reduces over -9 over +2. If you're not good with the mental math, you can just go to your calculator, do second mode to get out of here, and then just hit alpha y equals, and enter to get your fraction box. And then we're just typing in 3 minus 12 on the top, then arrow down, and then we're doing 0 minus a -2. And there it would reduce it for you, okay? So there's really not an excuse for missing this on minor careless errors of simplification. The calculator will do that for you. All right, now we're graphing. In order to graph, we still need it to be in this form right here, y equals mx plus b. So I'm just going to write this underneath here because, let me write this. Whenever it has to be in this form to graph, because when it's in this form, we will graph the b, the y-intercept first. Okay. And then we will use the slope. Sorry, fix this. Second, we're going to use the slope, which means, let me just fix this a little bit. Whenever I'm using the slope on the graph, I'm counting the rise over run. Sorry. Okay. So this equation is not in slope-intercept form. So we need to first put that in slope-intercept form by adding the 4x to both sides. So this term would cancel. All right, so I'm going to rewrite it over here to the side. I know we don't have a lot of room. So this is going to turn into 2y equals 4x plus 10. We still have a number with the y, the coefficient, so I have to divide everything by the 2. Okay, so now I can see that the equation is really y equals 2x plus 5. So I'm starting with the 5 on the y-axis. Put a point there, and then I'm using the slope, which is the 2. That m as a number, as a rise over run, is like 2 over 1. So I'm counting up 2 and to the right 1. Up 2 to the right 1, and then plotting a point there. The thing is, I can't repeat because I'm running off the graph. So I have to go in the opposite direction. Down 2 to the left 1. You just need 2 points to graph a line. So we just need to draw a line through these points that we have here. And then there's our graph. Now hopefully on 48, we recognize our special types of lines, which are OI and VUX. This one has y equal a number, so it should be horizontal, H. So we have a point there, and we have a horizontal line going through the 4. 49 is not in slope-intercept form, but to get it in slope-intercept form, all I have to do is add the 5x. And so I'm going to write it down here. Our equation is y equals 5x plus 2. This is what we should graph first. And then our slope right here, that is second. And that we will write as, 5 over 1. So if you can't count, I don't think 1, 2, 3, 4, 5. Yeah, you can get the 5 on there. So if you can't make it fit, you just got to go in the other direction. All right. All right. And then you look at the next page here. because we have to get to, I believe, 61 is part of our next check. Let me look at the, yep, 61. So if we look on this page, they want you to write the equation. So we're writing the equation still in mx plus b form. So that means you have to find the b first. That we can physically see off the graph. Our b here is a -2. Let me change my font, sorry. Our b equals a -2 here. Then I need another point. So I could put another point right here, I believe. Yeah. And now I can use that to count my slope. This is the rise of 1, and then over to the right, 1, 2, 3, 4, 5. So my m here is 1/5. Now I can write the equation. I can put it together. So y equals 1/5 x, then -2. Okay. So if they give you the order pair, like they do on 51 and 52, then you could use your slope formula to help you see. I probably need to move that up. You could use your slope formula to help you get to that point, to get the slope, the m, because this represents, you know, if you have points, like they have points here. Okay. What I'm trying to focus on, or what I'm referring to, they wrote the order pair here. Okay. So you could use that if you're not good at counting. Okay. So I want you to do this section. All right. Now I do want to talk about 5s. Decide 55. Sorry. Decide which of the 2 points lie on the graph. Now this one's a little tricky. We still have to solve for y. So that means we're doing the -2x, -2x. I'm going to do that because I'm going to show you a shortcut. Okay. This is important. Always being able to solve for y, -2x plus 10, can help me let my calculator do the work for me. So if I put this into the calculator, so I go to y equals, let me clear that out, put a -2x, it was plus 10. And then if I go to my table, which is second graph, we're trying to check the 0.43. Well, if I go down here, 4 is supposed to map to 2. So 4, 3 is not on the line. And like basically, if I looked at the graph, and if I was at 4, 1, 2, 3, 4, 3, it would be off. It would be above the line. It wouldn't be on the line. Now, the next point we're looking at, if you look right here, is 24, 18. So you can either scroll down, go back to your table, second graph, and just go down all the way to 24. That takes a while. Okay. There's a shortcut. If you hit, and anything in blue means you have to hit the second button first. Okay. And up here in the top, this is TBL set, table set. Meaning set the table. Set where you want to start. So if we hit second window, you're going to see this screen. It says table start. Right now my table's starting at 4. Well, I want to check to see what would happen if I started at 24. So I'm just going to type in 24, hit enter, and then just hit second graph to go to the table. And now it's at 24. But with that equation, the y value should be a -38. So on here, neither of these, none, work. Okay? Neither of these values work. So you just have to check, okay, using your calculator. All right, so on our last section here, it says write the equation, put linear equations in slope-intercept form. So slope-intercept form, again, that's when we have y equals mx plus b. Now, if you're given the m and the b, you can go straight to plugging in. But if you're giving, basically this m represents the slope, and this is our point, then we're going to have to start off with point slope form, which is y minus y1 equals m parentheses x minus x1. Now, we'll talk about a shortcut if you recognize certain special points. But we're going to first, because you're going to need this for all of these problems, 50, 60, 61. So we're going to plug in the slope where the m is, right there. It goes in front of the parentheses, and then we're going to plug in our values for our point. So that means we're going to have y minus 2 equals the slope, which was that -4, parentheses, x minus the 0. Okay. Now, to put this in point slope form, we're going to simplify this. We can simplify what's in the parentheses, or we can just go straight to, if you look here, distribute, sorry, this -4. Well, y minus 2 equals -4x. -4 times 0 is just 0, so I don't need to put a 0 here. You could say plus 0 if you wanted to. But now we're solving for y. So to do that, you're going to have to add the 2. So our equation in slope-intercept form is y equals -4x plus 2. So this is what I wanted to talk about. If you look, here is our y-intercept. Okay. And if you look at our point, this point was the y-intercept. There's some information that helps me see that. So if I was just looking at a graph and I was graphing this point, like if I use this graph as an example, this means I go 0 up 2. For it to be on the y-axis, the x value has to be 0. So if my point has a 0 in place of x, and then I have the y, then I know that's the y-intercept. So I could have skipped all of this work and just went straight to seeing that this b was 2 and plugging it in. That's if I recognize that. Not everyone recognizes it. But everything else here, we don't have special points. We don't have the special point y-intercept because there's no 0 in the first coordinate. There's no 0 here, okay? No zeros in any of these points. So we have to start off in point slope form. So like this would be y minus 3 equals 1/3 parentheses x, not minus a -6, that turns into plus 6. Then we're going to distribute the 1/3 to get rid of the parentheses. So where you write everything, y minus 3 equals 1/3 x plus 2. 1/3 of 6, or 6 divided by 3 is 2. Now we're solving for the y, so we have to do the opposite of that -3 to plus 3, sorry. So our equation is y equals 1/3 x plus 5. Okay. So I want you to try to use this point slope form to go into slope intercept form. The difference between the bottom 3 here is we don't have the m, but we can find the m by using the slope formula. So this is x1, that is y1. The first coordinate is x1 and y1. This is x2, and that's y2. So we're just plugging it into the formula, which is I have a -10 minus 4 on top, and then 4 minus 6 on the bottom. We can use our calculator to do this. So if you just go back, hit second mode to get it like blank screen, y, or the alpha y equals, and now we're just plugging in our numbers. So we have a -10 minus 4 on top, arrow down, and we have 4 minus 6 on the bottom. We hit enter. There's our slope. It simplifies to 3. Okay, so we are now, oh shoot, I just realized I typed that in wrong. Let me go, I'll fix that out. I'm gonna copy this and I'm gonna arrow up. Oops. This, I knew something was off. It should be minus here, right? Yeah. Okay, it turns into 7. 7, sorry about that, guys. So, I go here, this is 7. There's my m, so I can use this as my slope. and I can use this as my point. So I'm just going to plug that into point slope form. So this would be y minus 4 equals 7 parentheses x minus 6. Then to solve it, we're going to distribute to get rid of the parentheses. So we have y minus 4 equals 7x minus 42. And then we're going to solve for the y. So we have to add the 4. And we get y equals 7x minus 38. Okay. So you could get a bigger number. All right. Now, I do want to talk about the last one, 61, real quick, using the slope formula. So I'm going to go straight to the calculator part. So I'll do alpha y equals. We plug in our numbers. We got 5 minus 1. Then we have negative 4 minus negative 4. Enter. Okay. So this is error dividing by 0. Meaning, if I was to simplify this and show you what would happen, we have basically 4 over 0. Whenever you have 0 at the bottom, like this means undefined. Okay, or you can abbreviate U and D. So you got to think of yourself, what lines have undefined slopes? Because this is what we're finding is the slope. And this kind of the acronym, we got to remember. Remember when I showed you OI Bux VUX. This one has the U, which means an undefined slope. So we're talking about a vertical line. Vertical lines go up and down. They're going up and down this point. The equation has to equal a number. The number is the x. Notice this, the x's are the same. So anytime I see the x's are the same, it's going to have to be a vertical line. So the equation here is just x equals negative 4. All right, so that helps you with that section. Use our video help for the last section. You're ready to check and study and review for your final exam. All right, thanks, guys.